Today we're going to do revisions for chapter 2. So this is the final answer for today's revisions questions. Questions 1. A 2 microfarad capacitor is charged using a battery of EMF 1.5 volt. The charged capacitor is then uncharged through a 60 kilo ohm resistor. A. Calculate the time constant of the discharged circuit. B. Find the time taken for the charge on the capacitor to decrease to 1% of its initial value. To calculate the time constant, you can just apply the equations for time constant since you are given the values of resistance and also capacitance. So by using equations tau equals to RC, substitute the values and you will get tau equals to 0.12 seconds. Now, there's one thing that I would like to remind you guys. This equation, tau equals to RC, it is not the definition for time constant. When it comes to time constant, the equations is for the calculations and the definition, it depends on whether you're looking at charging process or discharging process. Questions B. To calculate the time taken to discharge a capacitor, first, you need to understand what does it mean by the charge on the capacitor decreased to 1% of its initial value. It means the final charge stored in the capacitor is now equal to 0.01 of the initial charge in the capacitor. So since it is a discharging process, therefore by applying the equations for a discharging process, Q is equal to Q naught exponential negative T over RC. This E right here, it refers to the exponential. It is not the elementary charge. So these equations can also be written as Q equals to Q naught exponential negative T over tau. We use tau in this equation because we already have the value from questions A. So next step, what are we going to do? We substitute the values into the equations. So Q equals to 0.01 Q naught, as you can see here, equals to Q naught exponential negative T over 0.12. So this 0.12, you got it from questions A. After that, what I have to do is to cancel out the similar terms on both sides. So you have Q naught on the left-hand side and also on the right-hand side. You can cancel it out. And therefore, the remaining equation is ln 0.01 equals to negative T over 0.12. So you rearrange the equations. You take this exponential to the other side. It will become ln. And then you solve the equations and you will get T equals to 0.276 seconds. A parallel plate capacitor has two plates of area 150 cm squared separated by 5 mm of air. Questions A. Find its capacitance. B. If the capacitor is connected to a 500 volt source, find the charge on each plate. C. If a minor sheet of dielectric constant 3 is inserted between the air gap while the capacitor is still connected to the 500 volt source, how much additional charge will be stored in the plate? D. If a minor sheet of dielectric constant 3 is inserted between the air gap after the capacitor is disconnected from the 500 volt source, how much additional charge will be stored in the plate? Questions A. Since you are given the surface area of the plate and the distance between two plates, therefore you can apply the equations for the capacitance of a parallel plate capacitor to solve this question. C equals to epsilon A over D. Now, the reasons why we use a subscript note here, because the material between the plate right now is the vacuum. Substitute the values into the equations and you will get C equals to 2.66 times 10 to the power of negative 11 farad. One thing that you have to take note is the area. Area is given in terms of cm squared. So 1 cm squared is equals to 1 times 10 to the power of negative 4 meters squared. To calculate the charge on each plate, you can simply apply the equations for capacitance, which is C equals to Q over V. Rearrange the equations. Q is equals to CV, and substitute the values into the equations. You will obtain Q equals to 1.33 times 10 to the power of negative 8 coulomb. Question C. It asks you what happens to the charge if you insert the dielectric when the capacitor is still connected to the battery. Now, the keywords right here is battery is connected. What happens if it is still connected? If battery is still connected, then V is constant. What does it mean by V is constant? Well, it means the V before you insert the dielectric is equals to the V after you insert the dielectric. Next, we're going to see what happens to the capacitor after you insert the dielectric. So by using the equations in the list of formula, we have epsilon R equals to epsilon over epsilon naught, where epsilon R is a dielectric constant, and epsilon naught, both of them, they are the permittivity of free space and the dielectric material. So what are we going to do next is to expand these equations to see what is the effect on the capacitance. So by using equation C equals to epsilon A over D, rearrange the equations and you will get epsilon equals to CD over A. Now substitute these equations into the equations on the left hand side and you will get CD over A divided by C naught D over A. So CD over A, now D over A, D and A, both of them, they are still having the same value. Because you are not changing the physical structure of the capacitor when inserting the dielectric, you are still using the same capacitor. So therefore, D and A, both of them, they can be cancelled out from this equation. And thus, you will get C over C naught. Rearrange this equation. C is then equals to epsilon R C naught. Substitute the values into the equations and you will obtain C equals to 7 times 10 to the power of negative 11 farad. Now that you have the new capacitance and you know that V is constant, you can then calculate the values of the charge. So Q equals to CV, substitute the values into the equation, you will get Q is now equals to 3.99 times 10 to the power of negative 8 coulomb. So as you can see right here, the V I'm still using 500 because from the terms battery is connected, we know that V is constant. But that is not the answer of these questions yet, because question asks you to calculate the additional charge. Therefore, what you have to do is to use a final charge minus initial charge. So substitute the values into the equations. The additional charge in the capacitor is now equals to 2.66 times 10 to the power of negative 8 coulomb. Questions D, now it asks you what happens to the charge if battery is disconnected when you insert the dielectric. Again, the keywords is related to the battery. If battery is disconnected, then Q remain constant. So if Q remain constant, it means that there's no additional charge after you insert the dielectric. So that's the answer for questions D. So that's the end for today's revisions. I will see you all again tomorrow.